Hello students, this is a class 3 of algebra. Already we have seen some of the definitions and more about the three theorems. We will continue with the next theorem. Okay, right. See here, prove that characteristic of an integral domain is 0 or prime. Okay, here characteristic of an integral domain is 0 or prime. Already we have seen the definition. Characteristic of an integral domain means the order of an elements. Okay, so the integral domain, the ring R with addition and multiplication with characteristic of R is n. Let us assume that the characteristic of a ring R equals to n. Actually we need to prove n is 0 or prime we need to prove. Okay, so but I am proving this theorem in the contradiction way, and I am assuming our n is not equals to 0 and n is a non-prime. Okay, so if n is a non-prime, it is a multiple of a two integers. What is a prime? Either it should be multiplied with 1 or itself. Okay, so here our s and t lies between 1 and n. Okay, s and t lies between 1 and n. Now here already we are saying with the definition of an integral domain, we will take for all a not equals to 0 in R, there exists a into a is equals to a square belongs to R, and a square is not equals to 0. For all a is not equals to 0, we are taking a square is not equals to 0. R is an integral domain. Okay, right. N into a square is equals to 0. What is n here? N is nothing but st. St into a square equals to 0. St into, what is a square? A into a. So s into a, t into a is equals to 0. Therefore sa is equals to 0 or ta is equals to 0. If sa is equals to 0, then for any x belongs to R, if we are taking another x belongs to R, so sa into x is equals to 0 if and only if as into x is equals to 0. If I am taking as into x is equals to 0, by the distributive law, a into sx is equals to 0. Therefore sx is equals to 0, because a is not equals to 0 because it is an integral domain. So which is a contradiction, to our assumption our s is lies between 1 and n. Okay, so it should not equals to 0. So if the characteristic of R is equals to n for an integral domain R, then R has no factor s with 1 is less than s is less than n. Therefore n is a prime. Means we took here n is non-prime. Okay, so this we got it as a contradiction. Therefore it is a prime. Simple theorem. Right, see the next question. If D is an integral domain, then prove that D of x is an integral domain. Okay, so D is an integral domain means it has no zero divisors. Now we need to prove D of x has also no zero divisors. Okay, so D is an integral domain. So by the definition of integral domain, it should be always a commutative ring with unity and has no zero divisors. Okay, if it is an integral domain, what is the definition of an integral domain? A commutative ring with unity has no zero divisor. Okay, so since D of x is a ring, if D is commutative, D of x is also commutative. If D has unit element 1, f of x is equals to 1 is the unit element of D of x. Here I am saying D of x is commutative and D of x exists unit element, means a commutative ring with unity. Okay, so we need to prove only D of x has no zero divisors. D of x has no zero divisors because already commutative ring with unity is satisfied. Okay, now we will assume f of x comma g of x be non-zero polynomials in D of x. Okay, so f of x we will take one polynomial, g of x we will take as polynomial. Since already we know that D is an integral domain, okay, am bm is not equals to 0, f of x is not equals to 0, g of x is not equals to 0. Therefore, their product f of x, g of x is not equals to 0. Therefore, I can say that d of x has no 0 divisors because it is not equals to 0. Their product should be equals to 0. Then it is a 0 divisor. If the product is not equals to 0, then it has no 0 divisors. So, we took d is an integral domain. We have proved d of x is an integral domain. Okay, so means the d is an which has no 0 divisors we took, and we have proved d of x has no 0 divisors. Okay, so this is one of the most important theorem in third and fourth unit. We will see this one in the next class. Okay, so once I am showing you the important question, these are the important questions in unit 3. If you want, you can take the screenshot. Okay, this is the long questions which are repeated questions. You can take the screenshot, and these are some of the important short questions. You can practice these all questions. So we will see this R by A theorem, which is the most important theorem, in the next class. Okay, thank you.